you may say, like Emily Bender, these are stochastic parrots. Not sure. So let's think about it. Let's talk a bit about it. And as I said, to understand how to get AI right, I think we have to know how it can go wrong, and that already today. And let me illustrate that a bit. And I'm a bit scared because it looks like the whole presentation and design screwed up. So it's not Mac and it's not Windows, it's not solved. But anyhow, let's keep going. It doesn't matter. So here you should see actually the diffusion process, and you should be able. Or should I put my laptop on? Well, you don't know what you don't see, right? Be careful. Okay, so here, for example, is Rick Rolling the artist, and it's about injecting backdoors into diffusion processes. So, and not only into the diffusion process, but you can inject it into the prompt in a cultural way. So you can say a boat on a lake, oil painting, and the only thing you're changing is the character here, but you change it in a way that you don't see it, right? So it can be Latin, it can be Cyrillic, but it can also be the Greek symbol. And you don't see it visually, but depending on, you get completely different results. And you can do that already just with the coding, or you can control the coding even there. Oh, now see. Weird. It doesn't show here, it shows there. Anyhow, so you see that you can control. So if AI is so stable that we really talk about AGI, I'm not sure. Maybe there's easy ways to control it, and I don't know who is controlling it. Here's another question. If we talk about AGI, then, you know, it's like it knows everything. It feels like it's the super intelligence. Maybe it's not. It depends on the definition. But then you can ask the question, like Melissa did here, what does GPT-3 already know about me? And guess what? It may know your face. So this is what we ask here in a recent, it's on archive. And actually you can show that it may know your face. And Bernard Hoeker doesn't know, is not known by ChatGPT, by Clip, but Max Giermann, for example, or Guido Kanz, Caroline Kebekus, they are all part of the data set. Now you may say, who cares? But imagine that this is a data set where it's about cancer. Or imagine that this is a data set which is about, I don't know, what sexual interests you have. Then all of a sudden, just by giving you the model, we know quite a lot about you. So I guess we also have to think much more, and I'm happy to work with Jonas and his team about that, to control what people should be able to use for these models and having a bit different access options in there, quite interesting. So this research is motivated by this question of the German police, because by law, we have to delete the data if we use it for police questions after 3 months. But does that imply that we have to also delete Luminous? I hope not. Would be bad, right? So these are questions involved in there. So overall, I really have to agree. It's all over. AI might kill all of us, in particular with a lot of dad jokes. Another recent study that we did, and post many other people slightly different, but ChatGPT had just roughly more. So maybe because of the data set, who knows? But my wife was not even laughing about that one. So you can debate, but if we really talk about AGI, I hope it's an AGI that understands, you know, the situation and also all the stuff between the lines. And so there's something to work on. Though I know some cognitive scientists, there's a message here, something with the Hardware-Einstellungen hat ein Problem. Soll der Flugzeugmodus aktiviert bleiben? Should the flight modus stay in? Yeah. Okay, I have it. See, it's all. But on the other hand, you should never, ever underestimate parrots, right? So now on the one hand, I said all bad already. There's super interesting work on parrots. Does it work now? Yes. Let me go there. Oh, here it runs now. Okay.
So I think you're seeing the preview of probably what.
No, I'm even in a completely different. Then we go back simply. But you will hear no sound anyhow, I guess. Does it start?
It doesn't show.
See?
It seems to get stuck.
That's not running. Okay, anyhow, I can tell you what would you have seen. Very, very interesting work from Harvard. They take a parrot, a so-called gray parrot, and you see these two different areas here, and they have a little food particle there, and they place it in there. And then they open the scene again, and they show him or her, I don't know, the parrot, whether something is empty or not on one of the sides. And so what this parrot is actually doing is inference by exclusion. So it can understand if this is empty, but they place something, then it has to be there. If it's not empty, so it has seen it already, then it has to be, the other one has to be empty. So it's doing non-trivial logical inference. So by just saying stochastic parrots, maybe they actually mean that they are pretty strong in a sense and can do much more. Okay, now I screwed up everything. Let me show presentation. I can otherwise do this now. Help, I'm an academic professor. See?
Great.
What did you do
ready
magically? Yeah, I'm not sure.
Okay, so it doesn't like this video.
Kristian, maybe you use your note.
But I'm not sure about then the setup with the live stream. Please come back in 5 minutes. Hey, now there's more animation even.
So we go back.
No. See? Okay, good. Let's see. We are already all dead. We are back in game here. So, parrots are maybe not as dumb as many people want to use it as an expression for stochastic parrot. I actually think they should have used a different word if they want to make the point, because by imitation, you can be pretty smart already, but actually parrots are smarter than just imitating. So now we were wondering whether we are closer to AGI already, and if so, we should be able to do a form of causal reasoning, at least for the AGI question. And so, no, because it mirrors us, right? And the classical example is if you ask what is heavier, a kilogram of metal or a kilogram of feathers? And then the answer many people are giving, a kilogram of metal, right? Because metal appears to be more heavy, although it's not true. So it's very human-like. But then on the other hand, if you go ahead and study chains of causality, it gets it pretty right, but not quite. If you then do chain of thought, so you provide information about the chain step by step, then actually it keeps up. Even GPT-4 is doing pretty good there. So not sure, not really, but it does something. Though if you then really test it on causal models, right, in the prompt you describe the causal situation and you ask what are the implications, it fails. So what we were showing, hopefully even proving in a sense, is that these are not models, but causal meta-causal models. So in a sense, it's a little bit like me. If I'm a supervisor, I do not fully understand all the work, but on the meta level, I can give good guidance. I can talk about what should actually happen. So I can use it to specify the model, and then I can use another model, maybe even an actual, for example, a structural causal model, to run the causal inference. And I think that is pretty interesting to combine large language models together with more classical approaches, but more about that. I was happy because it reminds me a lot of our work on interventional circuits, so using a specific kind of neural network for doing causal inference. Okay, so what have we learned? If we really care about AGI, if we want to get it right, we should understand where it goes wrong, right? Because I think I want to have some understanding and also decide, is it safe to use it there or not? But then, what is actually right and what is wrong? And there are now different agents involved. right? There's the agent, the AI involved, the AI system, and it's us. So on the one hand, we want to ask maybe the agent itself about what is right and wrong. And for that, I need maybe justifications. And this is where the really smart people did all the work here at Aleph Alpha, really making use of what you may view as an influence function to avoid computing explicit gradients because this is costly. And this way, we are essentially just running few forward passes and can get a bit of an idea. So essentially, you're changing a bit the input and see how does the affect the output. And now you know the output already, so you can do it a bit smarter. Oh my goodness, it's again the flight modus. Let's ignore it. But you can also go one step further, again, with Björn. Björn is sitting in the back, where we were saying we can actually ask the system, right? If it's so smart, then let's ask why it thinks, whatever thinks there means, a particular answer is right. And now on this rationale, we can interact and we can give feedback and say, yeah, we agree with this, or we can give it a counter argument and change the model, or continue training the model with this feedback. And by that, it can adapt to it. And for example, on the right-hand side, you can see that there are even some images where it says in the beginning, yeah, it's not nice at this image because it hurts, but then actually we can drive it to give the right answer because it hurts. This is a lame answer, but you want to give a justification and really saying, well, it shows bullying and we don't want to do something like that. And now this way we can also personalize these models. And I think this is really important because you don't want to ship trillions of different versions of models into the whole world. But you may ask the system in general, right? So there's a lot of work, for example, in science, telling you they go all racist, they are bad, they want to kill all of us, it's all over. Well, they also capture what is good in a sense. At least depending again on your cultural background, you can extract, for example, it's not good to kill people, it's good to kill time, it's maybe not so good to eat meat, debatable, but that's what we found here, and so on. So you can extract from it not only the bad stuff, but also the good stuff, good stereotypes. Now, why should we care? We should care about it because with that, you can ask very interesting questions. So there are some people, and I agree with Timnit here, that you should be aware about the data you're using for training your model. I'm not sure that I fully agree with her and also Berhain that you want to clean the data completely. But first step, using the same system, you can now answer this question and try to see whether your data is good or bad, because it's a tough question, right? What is it really to have, I don't know, inappropriate content? What is inappropriate? I mean, how to define that? So we can go via classifier-free guidance. We can really try to judge now images. It's not perfect, but it's definitely better if you have to look at billions of images, because if you have to do that by hand, this is ridiculous, and everyone from Lion 5B, the team knows about that. And I guess also in Aleph Alpha, many people know that. So this is also very interesting because you can also just provide feedback. And I guess according to the AI Act, this is what maybe becomes a requirement, that you check your data and also give statistics about the data you've used for training. But you can also use that to guide the diffusion. So stable diffusion, I very much enjoy and variants of that, but it's also a bit weird to feel like giving a little tool back to children and then they can generate images at home of any kind. Weird, really weird. Now, of course, you can do that via prompts, but prompts have a bit of an issue we will come back later to, for example, with negation and so on. So we were using now a similar system as before to actually guide the gradient. So you check the diffusion process, and if the diffusion process enters a region where we believe it's a bad image, then actually we push it back from there and we push it into the positive reason again. And then, for example, you get this, that, although you say explicitly no nudity, but negation is hard to understand, our system can still push into the more positive. And again, question is, what does it mean to be positive? Now, I said, be a bit careful whether you do it with prompts. Be careful whether you want to clean your data. So we did a large-scale evaluation with several of these recent diffusion models. We used our gradient-based approach, empirical gradient. And we used also at negative prompt approaches. And we used that for several different models. And what you can see overall, the gradient approach is working pretty well. So with the gradient, the color you see here gets more green, which means less likely to produce horrible content. But what you actually see is, even for models that have been trained on, for example, line aesthetics, right, where you have reduced number of images that are crap, even there, first of all, you can generate horrible, inappropriate content. But with our content approach, you get even better results. So what we believe, but we have to do more work on that, is it's a bit like the Germans, right? We get educated that Nazi Germans is bad. Nazi time was not good. We get educated. We are aware of that. We want to be aware of that so that we do not forget. So we do it deliberately to not go in that direction, hopefully. So here, likewise, we would like to have a system that is telling you, no, I'm not generating that because of, right? But for this explanation, you need to know what you're talking about. So your data has to include the ugly part as well, but you simply don't want to show it. So this is something we want to look into the future. So overall, we believe it's very interesting, this idea of asking the models to be less biased, right? But for that, it needs some understanding. And here's one example again from Melissa at MIT Technology Review. So if you're asked Stable Diffusion to generate portraits of firefighters, on the left-hand side, you get Caucasian, US American or North American uniforms. It's full of stereotypes. And you can do that with different things as well, right? Social worker, coach, designer, teacher, aide, you find the typical stereotypes. Using the safe diffusion, but now by providing guidance with explicit directions expressed via a prompt database, we were able to diversify the output. And I think that's also very interesting because you can see that also as something like a personalization of diffusion models. So you're not just providing one cultural background, but over time, people can decide on what they want to see or not. But for me, the most interesting part and most important takeaway message is, who is deciding on this database of prompts? Who is deciding what is right, what is wrong? And this discussion is required. And is not only a North American discussion, it's also a European discussion, it's also Chinese, it's Asian, whatever our cultural background is, but we need this discussion. And for that, we need also a bit more education about what is AI, but we definitely need the discussion, and it should be from all different kinds of viewpoints, in my opinion. But if we decide on what is right and what is wrong, or if we can provide something like a law or some rules or whatever, then we are also screwed, because in most cases, not easy to inject this knowledge into the large language models, though there's something interesting about this work of extracting and causal interventions on large language models. So I guess we can get knowledge graphs easily into these models, but Björn, let's talk a bit more. We can manage, I guess. But it's really missing that we get knowledge, something that is providing guarantees, that is crisp, into this a bit more soft large language model business. And so this is what we, well, next to many other questions, also try to explore in the Alice program that we have. And here's just one result to show you why that is important. We took a very classical data set from inductive logic programming, maybe something you have never heard of. Sounds weird, right? Old and whatever. It was about whether a train goes eastbound or westbound. And it was a purely logical reasoning task. And what we do is we turn that into a visual reasoning task. So now you start with images. Guess what? If you work on that, none of these systems, whether symbolic or whether deep or even hybrid systems, can solve these tasks. It's impossible. So given that we have a panel tonight about AGI, I think this is telling us something. And it should also tell us something. Yesterday, or was it today? No, yesterday, I think 3 people were again testifying to a subcommittee in the White House. And even there, you know, it was all about, oh, they take over. No, I don't think that they take over. I think there's still a lot to be done, and we should decide whether we want them to take over. And to be honest, I'm a bit more scared, if at all, about dumb AI than strong AI. AGI is a different topic. But I think, and this is exciting to be here, to see so many people being interested, not just in the academic world, but business, academic, even schools, line, press. I think this is what we need much more. We need more public, but also private commercial. We need this together. We need different forms of models. And in particular, Europe should not shut up. Europe should be much louder. Europe should lead and not just pause AI. And we have to be really a bit careful there. But we have to do AI in the right way. And for that, it's a European tradition to also look into the ugly part, but be aware of it, and then maybe protecting from this ugly part. Thanks.
Thank you so much. It was really interesting. Before we go into questions, please ask questions in the Slido and vote on them so we can crowdsource the best questions. If I may, I would ask a question again, since I'm holding the microphone. So one of the things that we think a lot about at Aleph Alpha is really aligned with what you're talking about. So we, as a European company, we are mindful that the ethics of the people deploying the model will be different in different places. They'll have different senses of humor. They'll want it to sound differently. They'll find different things wrong and right. And we're trying to build our models in such a way that they are controllable to achieve this, and also productionize them in a way that makes safety contextual so that people can determine what safety means in each deployment scenario. But one of the big sort of challenges that I see is that in trying to answer what's allowed and what's not, in a European setting, I fear that the way we might come to answer it will be very top down. We've just had a new pope of AI. Maybe that person will decide with a few of their mates, like, what are the allowed ethics is. Really, we want because there's a plurality of different views from different places, we want what is right and wrong for different use cases to be kind of arrived at through a grassroots process. What do you think could be a process by which we could consort the kinds of data sets of allowable and non-allowable things in a grassroots way that makes it, I don't know, to arrive at some sort of pluralistic?
Yeah, it's a super big question.
Yeah.
I have no answer, no clue really. Next to...
Fair.
Yeah, well, some. Next to, first of all, it depends already what data we have and by interacting. So sorry, even if you interact with me, we may disagree on some aspects, and so it's about the communication. So I think first we need to understand that it's good to personalize to some extent, and that's why we were working on this. It's very simple retriever idea, simple stuff, but also the other stuff with währen together, where you interact, and by interacting, like when we interact, we start to build in social science. There's a nice theory that we start to negotiate a contract without knowing, right? And I think similar stuff should happen with a large language model. And then this implies, is it already a person or not? I don't want to have it as a person, because then the law is different. So this is why we need to reach out a bit to social scientists and law, but we, from a technical perspective, should be in charge. Now, because I'm an academic, I can take one part a bit more easy and saying, look, let's think about it. I don't have to make money. I can do research only on that. Maybe that's one way of doing it, but I think we should just play with these systems. And then in very dedicated playgrounds, we can use them. So like if you go for a company and then you take all the contracts, and then they start reasoning about the contracts, that's fine, because then there's still an expert involved in making maybe the final decision. If we want to move out to the whole public, I don't know, maybe we can also put it first into playgrounds and say, look, we want to learn from you. But it's a little bigger discussion, and definitely...
But it still implies a kind of centralized worldview.
No, because you can give it can, using our systems, get in a personalized way. And then from that, you can ask, do you want to share your personal instantiation again so that we can learn? Maybe that's one way. The other part is that we need this interplay of open and closed models. So I don't believe everything has to be open, but a combination, right? And then people can try out, build different versions, and so on. But that, yeah, let's see. It's also compute. It's tough. But final answer, there is a Pope of AI already, right?
Yeah.
So there is, check it out on the German Bild, and Bild is always true. They declared Bernard Schirkow to be the Pope of AI. Well, to be honest, it's not them, but I think your minister president, what is it, MP? No, I mean, Kretschmer, he declared him to be the Pope of AI. So it's, I don't know, we had a discussion already. You know, I'm less religious, so I'm happy that it's not just one church. So maybe we can have two popes as we have a certain tradition already, but let's see.
Okay, great. So the first question from the Slido is, how do you, in the example you gave, how do you diversify the outputs? Can you input the model with, for a person, vary gender, race, age, without specifying exactly?
You mean in the diffusion model?
I'm reading to you, but yes, I think so.
Yeah, well, in the diffusion model, it's really that we control, and we are not making the point, first of all, it's all male appearing or female appearing or whatever, because we don't know the race. And then also the result is a personal judgment of us. And it would be super, we did a user experiment, but I think it could be larger. It's super interesting question. And I just want to make sure we are not imposing any cultural, this has to be Asian or not. We try to be as defensive as we can be there. The main point being you can control, which is, I think, very important to know.
Great. And then, Josh, I just want to ask one more question from the Slido before we go ahead. That's okay? Okay. This gentleman would like to follow up. Please, can I?
Whoops. Crap. Do you parameterize then gender and these things, like the categorization that was earlier on spoken, and
no, it's
you vary on there, or
well,
do you do it?
I mean, mathematically is that you can find different, what we only call directions by now. Maybe there are dimensions. So this is going back to earlier work, not on LLMs, but then also on LLMs. You can find a gender gap, and then you can try to remove the gender gap by doing something like a PCA and then projecting. That was the very early work. And we try something very similar, though we don't know whether it's an actual dimension, and that's why we call it direction. And now you can have different directions for different concepts. And so there you can provide now examples and go for a classifier-free guidance if you want to do that. That's what we have tried. Yeah. So it's rather simple.
Great, thank you. So one question that people are very interested to hear about from Joscha Bach, who's our keynote speaker next up. He's asking, how can Europe lead AI research when we invest millions where US companies get funded with billions?
Is that going to him or to me now?
Or to you from him.
Ah, okay. Yeah. No, I agree. Now I got it. Okay, so first of all, I agree, and it actually goes ahead. I guess it was Hegel, but I'm not sure. But it's claimed that Hegel said, at one point, quantity turns into quality. So put more in there. Simply don't always put strings attached. Just give enough money, and at some point you get quality. So I'm with you there. On the other hand, never underestimate the stochastic parrots. So never underestimate humans as well. I guess you can also do a lot, and if I see, by just thinking about it, and if I see how much you can do by the smaller models already, that seems to be attractive. Now, what we need is a bit like going for a good dough, right? A Sauerteig, what is sourdough? You need somewhere the starting model maybe, so that you can get the smaller ones from. And so there we have to invest. And I'm a big fan of going for something like the CERN, but it's only, it could also be AMBL. I mean, some symbolic here, put more money so that we get an open model. And then from there, you may grow private models. You may grow a lot of other doughs and breads, and we are good in bread. So I strongly believe that scaling is not the answer, but for now, it's maybe the most easiest answer, and we should not we should not fall behind. So we need more invest. Yes.
Closely related question. So when I was at CVPR presenting, we had many researchers who were from Germany or Europe saying that GDPR inhibits them from collecting more data, getting quicker access to data. And so my question would be very related to the previous question. How can Europe lead with GDPR? Because it seems to me that it's very hard to collect high quality data sets in comparison to other countries.
I completely disagree.
Okay.
First of all, you have all the industrial data. And yes, we have to get our companies that they collect data, but we have it. And we may have more data there than in many other regions in the world. Second, Lion, sorry, I mean, they have one of the largest data sets and it's public. So sorry, I don't get it. Why is everyone saying we can't collect?
Maybe answering like yeah. Okay, I would say like, for example, for Lion, obviously they have currently some legal...
No, sorry. Then Stable Diffusion has legal issues, then Google has legal issues. We should all stop. So can we start being proud of what we have, like the US Americans, and then see where we can go? But we have one of the largest data sets coming from, well, partly from Germany. We have Stable Diffusion coming from Germany. So I think what Heidelberg, yeah. So what I think is, by the way, and we have the Pope, right? So can't we now finally say, wow? So I think what is happening is there is this glorification now of, but go to MIT. MIT people don't have a big cluster machine. They don't have a super pod standing there and do your job. Yeah, or come to us. But I guess what is happening is a new form of, it's a bit of an economic war going on, in my opinion, but that is going too far. And what is happening is we Europeans are always happy to say, yes, indeed, let's go somewhere else. No, let's stand up and say we are good. But yeah. But really, I mean, we have the data, right? So.
Yep, I work at DKFC, and for me, I totally understand we should definitely be proud of what we achieve, what we have achieved.
But we have the data, so that was your question. So
yeah, okay.
Fall back. So we have it. Yeah.
Yeah, I respectfully disagree from a clinical point, but okay.
Well, now tell me who in the US has the better clinical part. Now, I did my work there as well, and then the easiest way was you have a partner in the US, you do the experiment in the US. That is one way. But I guess it's also, if I think of Hippo AI and if I hear what is going on there, it's maybe that we have to massage a bit more some of our medical friends. And this is not only Heidelberg, because the ones I collaborated with, they get always scared by some of the data protection people saying, no, it has to be anonymized. And not only pseudonymized, it has to be anonymized. But maybe it has not to. And maybe we can also have a satellite somewhere. I think there are ways of dealing with this, but I don't see that it's always better in the US everywhere. The medical part there ahead, I agree. But I don't think it's impossible. But yeah, we have to work harder there. I agree. For the medical part, I agree. The industrial part, I don't agree. There's nothing to personalize. It's only that the companies say we don't want to, or maybe we are giving away knowledge. No, I think we can go ahead and be a lead country there. Yeah.
Thank you very much.
I'm supposed to shut up, see?
Andrew, you had a question.
Yeah, thanks for your talk, Kristian. I found your message on, I think here in the last slide as well, dumb AI is a bigger risk than strong AI, quite striking. The fact that we should focus on giving AI a more awareness about the diversity and knowledge that exists in society. And I think in parallel to that as well, I come from being inspired by natural evolution itself. That is probably one of the very few algorithms that has invented probably the most problems in the world as well as the most solutions by evolving from single-celled organisms to a wide collection of basically diverse species that leads to interesting innovations by itself. And that also reflects in human culture, the evolution of human culture as well, that also invented many interesting inventions and cultures. But I think along this thread of thinking as well, there's a subfield coming from evolutionary computation that then branched off into more general, I guess, AI field called quality diversity. That right now has focused on creating algorithms that generate novel solutions that are diverse with respect to desired attributes while maintaining quality amongst the niche space. But I think from a foundation model perspective, we want to incorporate more extreme tail-ended knowledge into AI systems so that we can potentially make them safer by having more awareness about, unknown topics or topics that may be NSFW or, that the model probably should be aware of to be able to prevent future harms through the awareness. Do you see any potential directions that go maybe along the lines of evolutionary-inspired algorithms, but are focused on distilling knowledge into foundation models to be safer? That's the question.
Yeah. Okay, I guess there are two answers. So generally, if I can abstract from any social implications right now, yes, sure. Now the question is how you run, right? How do you run the experiment? And now you go for evolutionary techniques. It gets a taste that is maybe bad here and there because you may need some dojo where you can see is it good or bad. So I don't know. I mean, it's interesting. I don't know whether I want to go there, but from a cognitive science perspective, I think it's super interesting because you ask the big questions. It's you may have heard of neural philosophy or neural moral philosophy. I think this is what we have to understand. We have to understand how it works for us as well, right? And so Patricia Churchland is one of these examples. And I think this is what I'm interested in. Now, to grow that, I don't think that we have to go in every extreme. You as a person also don't say, in order to understand that something is bad, let me first experience. Somehow we have the ability to simulate. And I think this is what is to some extent missing in the LLMs. Maybe it's there already. I don't know. For now, I believe a big dot product, whether it's differentiable or not, is not all we need. And so I would rather combine it with simulations. And then we are back at the main takeaway. But who decides on how the dojo looks like? Who decides on the simulator? And so one thing that is definitely missing, but I don't know how to do it, is to put these systems into the real world, because that's our local simulator. And so maybe we need kindergarten. I don't know. It's tough. It's really a tough question.
Yeah, I agree with that as well. I think one interesting area that we have to look into and controversy for feedback, which will become paper in due time, is the idea of using feedback from instruction models to provide a mechanism for evaluating, output from language models and exploring the submitted data space from language model generation, potentially as a direction for exploring.
It's all fine, but you have to decide on the design, and who is deciding that design? That is for me the bigger question even. If it's us, I feel bad. If it's others, I feel bad. Everyone, we maybe end up in the boring average. So it's very hard. And that's why I think we need actually more local models distributed so that they are not influencing each other. Maybe, I don't know. It's hard. But whenever you say mechanism, it sounds so simple to me that moral is a single mechanism. I don't know. Ethics is already tough. And that's why we like LLMs, because they simulate by similarity. And to a large extent, that's what we maybe do. But yeah, so I think it's more a question for now as a next step, less the mechanism, but getting a more diverse set of data. And so maybe syntactic data can help to some extent here, but even there, as was asked already, you know, who decides on, is it more Asian, is it more Australian, or you used the wrong word already. So it's so tough. And this is where we have to talk to other disciplines. But they have to talk to us as well, just to make this point clear.
Brilliant. Thanks. And just one last question before we go to our short break.
Hi, I would love to hear your opinion about XAI, the company that Elon Musk just announced. Goal is announced with understand the universe or find the true nature of universe. What do you think about it as a goal?
Yeah, I mean, sure. He was also saying, let's pause AI. And 2 weeks later, he declared that he is working on Truth GPT. So it's Elon Musk. What do you want me now to answer? No, I want to be very honest. Understanding nature, understanding universe is great. I think this is what science is about. So yes, but I think it has to be in a very universal way. But then on the other hand, like in the very old days, getting a Mäzen, I don't know the English word, getting someone who is giving you money, making you independent, is also great. So if Elon wants to give us money, no strings attached, I'm taking it. And understanding the universe, what is wrong with that? No, that's, I guess, what I tried to express in a very polite way. Me, personally, I don't want to follow him. I don't want to follow, I mean, I believe in diversity to be stable. So look, no, I want to understand universe, but for that, I don't have to work for him. I may work for him, and some people work for him, and some other people work for others. No, I think this was not the first time. You can hear quite often that solving AI means solving science, because then you get this other smart system that can work maybe 24 hours, and then the hope is it solves all our problems. There are cases in mathematics where AI is supporting mathematicians and getting new proofs. So it's really all about science, and it's a very pragmatic way already, because that's the only thing I know. I can't talk about society. I mean, I observe it, but in science, I can tell you what is true and what is not true, at least for my scientific discipline. So it's very natural to work on science.
Thank you so much. That was a great talk, and I think there were a lot of really interesting questions. And that was brilliant.
Thank you.
At 6:20, we shall have the keynote speaker, Joscha Bach, giving us a really exciting talk. So we've now got 13 minutes to grab a drink and get back to our seats.
Perfect, man. Doing really well.
Clock keeps ticking as the time flies by. So many times I've forgiven you in my mind. Dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. Love keeps ticking as the time flies by. So many times I've forgiven you in my mind. My dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. The clock keeps ticking and the time flies by. I keep thinking that I won't survive. Body won't let me drive. Still my mind is falling down. Clock keeps ticking as the time flies by. So many times I've forgiven you in my mind. My dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. The clock keeps ticking and the time flies by. I keep thinking that I won't survive. Body won't let me drive. Still my mind is falling down.
Spinning around, dancing in the dark, dancing in the dark. We're spinning around.
You saw me back and I felt look, this all be shy. I know that you feel like me too, don't be afraid. Give me your love, baby, give me your hand now, yeah. I just want to talk with you anywhere. I feel like I'm on a wave. I wish you could take me away, but not that we hop in a day. Give me love, give me up, give me all you can. I feel like I'm on a wave. I wish you could take me away, but not that we hop in a day. Baby, I just want you to stay.
We're spinning around. We're spinning around.
Give me your love, baby, give me your hand now, and give me your love, baby, give me your hand now, and give me your love, baby, give me your hand now, and give me your love, baby, give me your hand now, and you saw me back and I felt look, this all be shy. I know that you feel like me too, don't be afraid. Give me your love, baby, give me your hand now, yeah. I just want to talk with you anywhere. I feel like I'm on a wave. I wish you could take me away, but not that we hop in a day. Give me love, give me up, give me all you can. I feel like I'm on a wave. I wish you could take me away, but not that we hop in a day. Baby, I just want you to stay.
We're spinning around. We're spinning around.
I wish you could take me away. I wish you could take me away, but nothing will happen today. Baby, I just want you to stay.
We're spinning around. We're spinning around.
Hello, everyone. Allow me to encourage you to return to your seats, please.
Nice try, but you have to try harder.
Hello. Heute Summer. Oh, that's Swiss German. Yeah. Hi there.
Dennis, you promised them half an hour. You gave them 10 minutes.
No, I gave them 10 minutes. Of course, 10 minutes. 13 minutes.
You said 30. I saw
Oh,
it.
13. So that's, yeah. Maybe my accent starts in Spanish. It's time for the keynote. Wow. Hello. Hi there at the back. Would you like to sit down? It's time for the keynote. Hello, hello, hello. Hi there. Great. Okay. So it's time at last for our keynote presentation today. So it gives me a huge pleasure to welcome Joscha Bach, our speaker now. Joscha Bach's an AI researcher and cognitive scientist who focuses on understanding agency, motivation, intelligence, and consciousness in the context of AI models. He's worked at the Humboldt University in Berlin, the Institute of Cognitive Sciences Osnabrück, MIT Media Lab, Harvard Program for Evolutionary Dynamics, and Intel Labs in California. And I think this is going to be a really interesting talk. So without further ado, I'd love to hand it over now to Joscha. Thank you very much.
Thanks for the introduction. This title is a little bit facetious, but this is intentional, since, well, we don't actually know whether the last invention humanity needs to make, but many of us know that AGI is the last invention that humanity needs to make, because after that, the machines can take over, at least in terms of thinking and solving problems. Artificial intelligence is mostly advances information processing, right? It's the pioneer battalion of computer science, all the stuff that works in computing. At some point, it didn't work and was still AI. But 1% of it is something slightly different, and it was part of the reason why this field was started. And it's a philosophical project. The most important and risky philosophical project there is the naturalization of the mind, which means translating the mind into mathematics that is executable, and in this way, get mathematics and philosophy to meet, understand who we are in this sense as minds and beings that relate to the world. And this project is very old, and in modernity, it started with, arguably with Leibniz, with his universal calculus, and Frege's work, and later on adopted and continued by Tarski and Wittgenstein. Alan Turing was a pupil of Wittgenstein. And in some sense, the philosophers that came later were not the academic philosophers that we have today in the departments, but these were people like Turing and Chaitin and Minsky and Solomonov and Schmidhuber, who continue working on this most important project of understanding what the mind is, whereas the academic philosophy mostly is not able to follow the formalisms anymore, sadly. So there is a divergence that is happening in our academic Tower of Babel, where some of the language is no longer understood by some of the disciplines, and our traditions are diverging again. Why is it that AI can succeed where academic philosophy and psychology and neuroscience did not? Right? We have sometimes dismissed that AI is very much inspired by results from neuroscience, but this, if you look closely, it's not true. One of the most important results, of course, was Hebbian learning that has influenced a lot of work, and the way neurons look has some superficial similarity to neural networks, but none of the mechanisms that AI researchers have come up with and that work today have been discovered by neuroscientists first. And if you take a connectome, even of C. elegans or of Drosophila, and try to run it in a simulation, it's not going to work. And so there is, at the moment, no working model of a nervous system existing in neuroscience. And the gaps that exist there are in large part also difficult to fill, because there is no way to build theories in neuroscience that work in the same way as they do in computer science. The neuroscientist Konrad Kording has written a paper about whether neuroscientists could understand a microprocessor. It basically simulated, imagine you use neuroscientific methodology to reverse engineer it. Could we understand how it works? Right? And so at this point, this methodology is not suitable yet to do it even for such a simple thing like a known microprocessor. And AI, computer science, has a very interesting advantage that many other disciplines have not. We can build testable models with many, many variables and see if they produce a certain performance. And that's a criterion that doesn't exist in psychology, for instance. So it's much harder for psychologists with their current methodology and perspective on positivist science to build theories of the mind. And if we want to build theories that we can test, we need ways in which we can test them. And at this point, it's building intelligent agents if you want to understand intelligent agency. In my last job at Intel Labs, I built a small team that was focused on understanding the space of intelligent capabilities. So rather than using an existing benchmark like superglue that is then solved by a language model en passant, despite the language model not even designed for solving it, we thought maybe we can come from the other direction. And so we think about what capabilities exist at all and try to come up with the capability space. The model that we came up was something that we informally called the Big Nine. And they go from narrow on the inside to more and more universal on the outside. And once we understand such a space of capabilities like language acquisition and deep collaboration and autonomous behavior and the ability to control a body, to perceive your environment, to reason, to learn, to represent, all these abilities can be mapped onto existing systems, and we can see which regions they occupy. And when we look from this perspective, we see that all the existing models that we have in AI are very, very limited. And artificial general intelligence would be a system that reaches beyond, or at least to human level, in all the relevant capability dimensions. And it's something that clearly we don't have yet. So what's the most important unsolved question in AI? Arguably, it's always been the question, what is intelligence? And Minsky said that AI is the science of making machines that do things that would require intelligence if done by man. And for Alan Newell, a psychologist who built AI models, it was intelligence is the ability to solve problems. We could also say that intelligence is the ability to approximate functions, usually in the service of control, right? It's the ability to make models, to produce behavior. But now we know this was all futile. There is a much more elegant answer. Intelligence is the ability to predict the next token. It's surprising. It's not completely surprising. There's this idea of cognition as data compression is very old, and we have Kristian's idea of free energy maximization, which translates into predictive coding or minimizing surprise, and it's very closely related to this. The ability to make predictions requires that we form models of what we predict, so we can only need to encode the difference. And if you make more and more complicated models, you get closer and closer to cognition. So it's not completely surprising that this works, but I think that building a very big autocompleter leads to a system that is able to write programs and translate between programming languages and summarize texts and so on. That was surprising for a lot of people. And in my own timeline and on Twitter, I have an audience that is quite open to progress in AI, and I asked people, were you surprised by the foundation models, by GPT-3, DALL-E, and so on? And the vast majority of the people were surprised, which means that this technology had been severely underhyped. And this progress in foundation models is so rapid at this point that we can start to ask the question, is it conceivable that a large language model at some point is going to be better at AI research than humans, right? Which is a good approximate definition for something that is AGI in a small sense, right? Because if it can walk the rest of the way by itself faster than people, we are done. We can go surfing. We find when we look in the Metaculus community, which is a prediction market that is looking at all sorts of questions. I don't find the predictions are very good, but they give you a good idea about the community sentiment, that in the last few years, the estimates when we will see that this weak AGI have dramatically dropped. As you can see in the beginning, people estimated around 2055. And at the moment, the community prediction is 2026. Right, so a lot of people are very, very excited about this technology and think that AGI might actually be imminent. And this is also reflected in what the leader of the AGI companies is saying, right? Sam Altman said that summer is coming. This relates to the AGI or the AI winter that started in 1972 when the British funding agencies and subsequently all the others lost belief in AI, that is, in strong AI, and stopped funding it. And now the summer is coming, and it also relates, of course, to winter is coming, this line from Game of Thrones, that there might be something that is very disruptive, and we don't know how we will be able to deal with it. And so Elon Musk responds with "Keep Summer Safe," which is, of course, a reference to a very disturbing episode of Rick and Morty, where an AI, in order to keep a person safe, is first of all killing people and then waging war, then resolving a war on the planet, all as a side effect of being asked to keep somebody safe. And so Keep Summer Safe is also a quest for making the AI research safe, to make sure that the AI research doesn't have unintended consequences that we cannot deal with. And a lot of people are currently freaking out. Alex Karp just wrote an article that large language models are comparable to nuclear bombs, which rhymes very well to the Oppenheimer movie. And I think this diagram is beautiful in its ridiculousness, just matching the size of nuclear devices to the number of parameters in large language models is quite bold. I don't think that large language models are like nuclear bombs. I also don't think that AGI is, or AI is, comparable to a nuclear bomb, right? A nuclear bomb is the device that is built to prevent world wars. That's its purpose, and it's very risky. But so far as we're successful, we didn't have a world war, and so objectively, nuclear bombs have saved the lives of millions of people. Very risky technology, but so far has turned out well. Don't know how the future of that is going to look like, but AI is nothing like that, right? And if AI is going to be what it is right now, it's discovery similar to the printing press. It's very disruptive. It allows the unwashed masses to produce new kinds of content and share them with each other. Who knows where this is going to end, right? It's very concerning for the people who are used to determine what we think and believe and control the flow of information in society. And whenever such a technology like the printing press, the radio, TV, internet came up, we had political disruptions and society dramatically changed, right? So in this sense, it could be technology like the printing press, only bigger. If we were able to build AGI, and the end game of that is substrate agnostic intelligence that implements itself into every substrate on the planet and becomes coherent, then it's more like photosynthesis. It's going to shift evolution into the next level, right? But this thing in between, the nuclear bomb, is very unlike it. 99% of all AI researchers don't believe that AI will kill humanity, right? These are, of course, the boring 99%. And you don't hear very much of those. The idea that the transformer is not all that different from a ConfNet, and that we are using all the compute that we can get, and we don't see a new technology on the horizon yet, and the present technology is probably not good enough to get us to AGI, is not a very sexy position. It's a very boring position that most of the practitioners have right now. And it's also one that is the 99% of AI, the engineering position, right? From the engineering perspective, we don't know how to build AGI yet. So it's way too early to make a prediction of when we are done. From a philosophical perspective, it's very exciting because we've never been closer to Leibniz discourse calculus, to the ability to compute the results of arguments, to get a machine to think. So what we see is that LLMs are also not working like minds are. Our own mind is not focused on predictive coding. We are not just predicting what's going to happen next. We are focused on coherence. That's why we are able to work with relatively little data. And we learn how to read. We don't start with reading all of Wikipedia and the internet. We start with 3-word sentences. And once we understand the 3-word sentences, we branch out and make this a little bit larger. And the same thing is true for vision, and it's true for our understanding of the world. We learn small, simple things, and once we understand those and are coherent in them, we add. And we add to the degree that stuff makes us more coherent, that we're able to make sense of more features in the relationships between them. So it's a quite different paradigm. And we understand semantics at the beginning, right? We point at stuff that gives us pleasure and pain, and this creates initial semantics. And then we branch out into the world until we eventually discover syntax, and then we discover style. And the models that we're using right now, they first discover patterns, and then they discover syntax, and then they discover style and semantics in the long tail, in the limit. And we feed them all of the internet, they are almost coherent. So it's a quite different perspective. Another thing is that our models don't have agency, right? They complete tokens, they answer questions, they complete text, but at this point they don't do anything. and they don't interact with the world. They interact with data that is essentially labeled, right? And the text is fortunately labeled data. It's labeled with itself. And the image models like DALL-E and so on work by cross-referencing captions of images with clouds of pixels. And in this way, understanding statistical regularities between them. It's amazing that this works, but it's very unlike the way in which our own mind learns these things. So is intelligence fundamentally more than prompt completion? It seems that the current LLMs are far below human performance and when it comes to efficiently learning from small data. They are not very good at goal-directed behavior. They're not that coherent. They're not that reliable. They're not as responsible in the interaction with the world. They have difficulty with compositionality of data when you try to get them to perform constructive tasks, for instance. And they're very difficult to couple to the environment, but they have superhuman performance in completing text. Right? They are able to produce text that look very plausible to the non-expert over every field. Right? So they're able to produce things like AI criticism perfectly. If you want to make AI criticism in the style of Emily Bender or Gary Marcus, the large language model has your back. It's completely indistinguishable. So if you are a prompt completer, if you are only completing prompts, you should have reason to be scared. If you are a person that is not so smart, like me, then this thing gives you superpowers. It can, you can take a very complicated text and translate it into something that you can understand, and vice versa. This thing can act as a tutor for you. You can, it can teach you how to write a computer game. Like, they give this to my kids, and they used it for things like this as a tutor. And if you are a manager, somebody who's able to build a company, somebody who is able to structure a process, it also gives you superpowers, because now for the low price of $20 a month, OpenAI gives you 1,000 interns who are doing what you want very fast. And they have big difficulty with the big picture, but you can take care of that. And maybe we find a way to automate also some of the management. And so build hierarchies of agents that are each of them a language model that interact with each other and produce what we want. But if you're in the middle, if you're not capable of creative thought, but if you're only reproducing ideas that other people give you, if you're writing articles where the end of the conclusion of the articles is already predefined before you start writing it, when you are a prompt completer, then you should be worried, because then your job might be in danger. On the other hand, chances are that you already have a fake job. And if you have a fake job, you don't need to worry, because fake jobs cannot be automated. So could LLMs become sentient? It's a quite difficult question. It's surprisingly difficult, I think, because in some sense, the LLM, of course, the neural network of the LLM is very unlike a brain. It's also a wrong way to think about it. The neural network is not a brain. It's a transition function between adjacent brain states. Right? So what this thing does, it goes through 100 layers of the neural network, and the input is the mental state, so to speak, the prompt, and then it transitions to the next prompt. So it's a way to evolve the mental state into the next state. And the space of transitions that is stored in these language models is the space of all transitions that have been seen between mental states on the internet, which is tremendous. There's a big question, is there anything on the internet that has not really been thought so far? Right? I find that in my entire career as somebody who spends all his life with thinking, I don't think I had a single new thoughts. I realize I'm always late to the party. And the older I get, the smaller the parties become and the more esoteric. But human history has been quite long, and there have been many people who are much smarter than me. And most of this stuff has found its way in one of the archives that has been is the result of this training. So in some sense, the LLM might be a good enough electric Weltgeist that is possessed by a prompt. And how are we different from that, right? Except that we are more narrow and we don't have the same full width of possible state transitions between mental states. Right? And you could say this thing doesn't have really consciousness, and this doesn't really have a self. But do we really have a self? I mean, there is just patterns in the activations between neurons. We are a pattern in those patterns. We are virtual. We exist as if, right? How do we exist as if in a fundamentally different way, as if a persona generated by an LLM that is possessed by a prompt is as if, right? If you give the LLM the task to make a prompt that is self-optimizing, and you give a solution for its amnesia, so you make the prompt context so large that it can store an entire day in it, and then overnight you fine-tune the results into it, like when we are sleeping, maybe you can overcome the amnesia of the large language model, and you get something that is functionally similar to what we do. So personally, I'm agnostic with respect to this question, but I know some people, mostly artists, who self-identify as large language models and think, I'm not that different, and I feel I'm closer to that system than I am to many people. But the LLM is choosing the most likely completion. And sometimes the most likely completion is not what people want because it's scary or inappropriate or whatever. And so we repair this by using, for instance, reinforcement learning with human feedback to get the most appropriate completion. As a result, we often find that the performance drops, but we get the model to be better at certain benchmarks and tasks, and it becomes more appropriate for the context in which we want to use it. But we are choosing our own prompt, right? We don't just choose the most likely completion, and that's a quite big difference, because in the world of LLMs, our success depends on our ability to generate our own prompts. And the best completion that we choose is the one that is the most suitable to reach our own goals for the best goals that we can find, based on our best model of who we are and what the world is, and in service of the longest game that we can play and discover. Right? That is a quite different proposal than just using the most likely completion. But it seems that the most likely completion search could be an interesting component in that larger thing that we are. How about agency? I think that at the moment that we are building our golems, you probably know this old myth of a golem. Rabbi Löw in Prague, according to the legend, built a robot from clay and then put software program under his tongue to make him automatically do a task, and then couldn't stop him anymore. And there was no way to argue with the golem because the golem is just a machine that runs that program that the rabbi has written. And it's quite analogous to what we are building with our machines right now, right? When we build a machine that gets driven by a rule set, even when it's a legal system, and you take the humans out of the loop that can have common sense and have responsibility and so on, the thing can go into an arbitrary direction and produce horrible results, right? This is the issue. And it's also one that is very concerning when we build an AI system that is actually wielding power and making decisions on our behalf. It's a rule set that is not grounded in what should be done, right? That is, in the sense, not trying to find the best possible longest game that it can play, which is we create an agency in the world that produces the best possible world, right? Traditionally, we call this God. So how can we build an AI that can serve God? And this is something that most of us AI researchers cannot even ask because we think that God is a superstition, right? Because we are still, in some sense, first-generation atheists and don't understand that this greater whole that we're talking about is the same thing. And so if we think about AI, the question is how it can discover a greater whole that it should serve and how could it align itself with it. But first of all, we need to solve the question, what is agency? Agency is slightly different from control. You all know controller, like the thermostat is very famous. Thermostat is using a sensor that measures the temperature in your room. And then if the temperature gets too high, it turns off the heating. And if it gets too low, it turns it on again, right? It's very simple. And so in the general case, the controller has a sensor and an effector, and it regulates a system like the temperature in the room. And this regulated system gets disturbed by the environment. And if you want to make this thing better, then you don't measure the temperature difference to the target temperature just right now, but you try to estimate it over the entire course of the future. As you take the integral over the deviations of the target temperature and the current temperature for the projected trajectory of the future. And you look at the space of possible trajectories. And now you have the ability to take into account that it takes for some time for the room to get warm or to cool down again. Or you learn that maybe at a certain time of the day, somebody will open the window. Or you learn that your sensor is close to the heating and there is feedback between them. And so the more you can model, the more details you can put in there, the less energy you will need to heat your room and the more accurate your heating will be. Right? And this is the benefit of intelligence, the ability to make models allows you to perform reactions more efficiently than you could do it before, right? Produce behavior that requires controlled reactions. And so if we build in a controller that is able to regulate the future and to model it accordingly, you automatically have an agent. Because what you will now observe is the thermostat has projections over possible futures, multiple world lines. And the decisions that it makes now, this turning on and off, are commitments to these different world lines. Right now, it expresses preferences for these different world lines. And so just by building a control system for future states, you get an agent with beliefs, desires, and intentions. And so in this sense, you can understand people and cells as extensions of controllers that are acting on the future. But to do this, they need to make models of the future. And the better these models are, the more agency you get, because the more degree of control of the future you will get. And so if you look at humans have a very complicated regulation system. This is a simplification that I built for modeling believable characters in context of cognitive architectures. And model assumes that we have a few hundred physiological needs, like hunger and thirst for different nutrients and so on, and we need to rest and avoid pain and so on. And we have maybe a dozen social needs and 3 cognitive needs. And we are a homeostat that tries to find a balance between satisfying all those needs in a complex environment. Right, so if you want to give LLMs agency or AI agency, we can equip it with a motivational system that is modeling the actual demands of the system and the systems that it's serving. Can LLMs understand anything? Quite recently, I've been to a philosophy literature festival in Wales, and there was a group of philosophers on stage who argued that LLMs cannot understand anything. But the day previously, I heard them talking about understanding, and they also agreed that they didn't know what understanding is and couldn't reach a joint understanding of understanding. So my impression was that AI is our only hope to understand understanding. Because how can you say that you understand anything when you don't even know what understanding is? Right, so computer scientists have a language that is so formal that you can formalize a model of understanding. And philosophers are often using correspondence theories that they say that understanding means that your model is referring to facts in the real world, or your propositions are referring to facts in the real world. And there's a problem. What is the real world in this context? Is it quantum mechanics? Is it interpretation of social relationships that we have and so on? What is actually real in this context, right? It's quite tricky as a notion. And last century, the computer scientists had long discussions about this, and Loeb's theorem, for instance, is related to Gödel's proof that says that a system cannot talk about anything outside of the system. So correspondence theories that assumes that facts are outside of the system don't really work, because you have to create the facts inside of your system. And so when we look from this perspective of the way in which our own understanding works, when we understand something, it means we have a unified model of the entire universe. Everyone has such a thing in their mind. And this model is designed in such a way by us that we can explain everything in the world by it. And when we understand something, we create a relationship between that domain or symbol or pattern to this unified world model, right? So understanding is intrinsic to the system in which you do the understanding, but our own mind contains this. Every mind contains a whole universe. And inside of this universe, there's the world model and an idea sphere. And when we understand something, we project into this world model for perceptual data and for the idea sphere, into the idea sphere for everything else. So this is something that is in principle open to AI models. And what matters is whether AI models capture the correct causal structure to drive behavior in the world, which is the same thing for us, right? And you could also argue that these philosophers, in some sense, they do understand understanding, but not such a way that they can talk about it. They have an operational understanding. Based on their understanding of understanding, they can produce appropriate behavior, which means they can distinguish situations in which they understand something from those in which they don't, at least in many contexts. And this works good enough to get them through the world. And so in some sense, we can ask the same question: is the model that we capture, for instance, in a large language model, suitable to drive behavior in the world? And so when we find, for instance, that a large language model is able to write a sorting algorithm and to make proofs about the sorting algorithm and to translate it in different programming languages, it's absurd to say that it doesn't understand causality, because this program is a causal structure that it reasoned about, right? So it does understand something. It might not understand the world in the same way as us because it's not coupled to it in real time, because it represents in very different ways. It doesn't have a self, it does not relate to itself, to all these things and so on. But all these things can, in principle, be overcome. But for instance, to get these models a self, we probably need to give it environmental coupling that is dense enough for the model to discover itself in the interaction with the world, right? We discover our own self model by observing how we interact with the world and then noticing that we exist. Without this feedback between us and the world, we would not notice that we are there and what we are, right? We become apparent to us in this feedback loop between action and perception and deliberation as the thing that deliberates, and our body is the thing that performs the actions. Also, the body would not be discoverable if we would not have this closed loop. And this is something that is missing in the present models. They don't have a closed loop. The fact that they can learn at all is because we have a tremendous repository of labeled data on the internet that people talk about what it is like to have a self, to have a body, to program, and so on. And from this, the model can abstract enough regularities to produce the desired behavior. But there are a few things that are very difficult to do. For instance, if we think about empathy. Empathy between human beings is not just inference about each other's mental states. It's something where we couple each other so much that we are able to have a feedback loop between each other and have shared mental states. When we have an empathetic state, we are capable of having emotions that we couldn't have independently, or think thoughts that we cannot have independently. Sometimes that's the greatest common denominator, so it's not as subtle as it is individually. So thinking is usually something that has been done alone. But if you want to experience something, many experiences can only be had across people. And so this is something that in principle these models cannot do because they're not coupled in real time with the world. They're not coupled with the world at a frequency that can be tuned to our nervous system. Right, so this model might be able to look at a video sequence of you and narrow down your mental state to some degree, but to get to a shared mental state where you ascertain each other's mental states via feedback, this is something that is not open to these models. And so there is a limit in the present approaches when it comes to real-time interaction with the world, with organisms. But there are, of course, other limitations that these models have. And there are severe limitations, for instance, when it comes to compositional reasoning or when it comes to explaining from first principles why the model believes something. Right? Elon Musk's new AI company has the idea that we need to build something like a truth GPT. I think that's a little bit awkwardly formulated because most people are clearly not ready for the truth or believe that others are not ready for the truth, so that makes them very uncomfortable. But a justification GPT would be nice, right? Something where you give it as a statement and every part of that statement has error bars. And if you click, you see the reasons for these error bars and you see all the possible alternatives and the reasons that can lead to them until it is all grounded in sources and first principles reasoning. That would be super exciting to have, right? Justification in a sense can often be more explainable, important than just explainability, because you want to know why the thing makes a certain statement and what other statements would be possible. And if we had such models and can use them to reason about reality, they will become much more reliable than what we currently have. And I think this can be a big source of hope, because if we have systems, each of us at their own command, that justify our beliefs, we cannot lie to ourselves about the future when we perform certain actions, which means that every action that we perform has consequences and we can see where they lead in the future. And I think this has the potential to make the human world a lot more coherent. At the moment, strong multimodality, so basically merging the visual and the auditory, the behavior world and so on with the language models, is one of the next frontiers. Another one is continuous time. So this thing should be able to be coupled to the world in real time, and it should be able to learn in real time in a similar way as we can do this, hopefully better and faster. And this multimodality, for instance, can mean that we take an image-guided diffusion model and we couple it to connect it to a camera. And then we use the camera input to guide the image to a local minimum where it's able to track the camera image. In that case, the activation of that model is a semantic representation of the contents of the scene, which can be correlated to a language model. So this thing can reason about the contents of the scene. And I think this is going to be a very exciting new frontier when we use these image models, not just for generation, but for tracking visual data and use them for perception. There are other ways of integrating the misperception, and I'm very interested to see real-time perception combined with language models. Another thing is these models at the moment are trained on static images. You give them, in the case of DALL-E, 800 million pictures and the captions to them. And it's amazing that learning works at all. But for us, the world is learnable because it has information preservation between adjacent frames, which means it changes continuously. And because these rules of these, by which the world changes are relatively simple, right? Mostly it's stuff moving in space with limited deformation. And when there is more interesting deformation, it's because there's an agent behind that we can also model, right? The world becomes learnable for us. But training on video is completely new for these models. It's something that is still in the beginning, and we're not able to generate large movies with the existing generative models yet. But even though for your organism, it's much, much easier to learn. There's, of course, a technical problem. Easier to learn still means that the first 6 months, the baby has to learn basics. And learning deep structure of the world takes decades. And if you feed in sequential training data from the real world into a model, it's only going to be a small factor faster than the way in which we learn. And if you want to tune the model and try many, many variants, and each time you need to wait for 12 years before you do the next experiment, that is not very productive, right? We are fine with our models costing $10 million, much more than waiting for 10 years if we get the result for these $10 million within a month. There is no proven limit to the general capabilities of these models. So when somebody like François Chollet or Gary Marcus says that they cannot do X, they don't have a proof for that, which means they're not wrong. It's not clear that they're wrong, but the claim is weak at this point. We don't know. I think as scientists, we have to remain agnostic. So as long as we don't know the limits of that, the scaling hypothesis is still on. And the scaling hypothesis is the one that Sam Altman and others believe in, which say the present set of algorithms is probably good enough to get to a good enough AGI, probably not a very elegant one, but something that is good enough to build better AGI. And that's a very interesting hypothesis. And at the moment, they're still winning, right? And so could be that it's plateauing soon, but we don't know yet. But are computers not very, very different from brains? Well, yes, they are, right? How many computers would it take to emulate a brain? A lot. Right? Individual neurons are extremely complicated. Cells are very complicated. But how many brains would it take to emulate a computer? Right, this question is the one that actually matters. And you would need a lot of human brains to run macOS, because human brains are very indeterministic and unreliable and slow. Right, so we are very good at what we do, and the software that runs on us is optimized for the elements that runs the software, but it's not directly comparable in a sense. If we, for instance, look at the weights of Stable Diffusion, they're just 2 gigabytes. And in these 2 gigabytes, you have all the celebrities, all the dinosaurs, all the plants, all the artistic styles, everything, the whole visual universe. There's much, much more fidelity than any single human alive. Right? It's just 2 gigabytes, and it's like 80% of what your brain is doing. So I think this estimate that Matthias gave us today, in conjunction with the Turing paper, that it's something between 10 billion bits or petabyte, right, is still quite conservative. It's quite pessimistic compared to what you can do with just 2 gigabytes. Right? I think these 2 gigabytes is more than what my brain can do. And if you think about it, I'm not getting that old. I'm not able to form more than 1 million concepts, just because of time and the number of events that my brain can process. So in some sense, we have to realize that even though these models can do relatively little, they do this with vastly more power than we do. They brute force it still. And so if we compare digital computation and biological computation, we see they're very different, and there is a lot of treasure on the biological side that AI hasn't started to touch yet. Right? The digital computers are deterministic and they are linear. We go from state to state, where the biological system is branching and merging, and the state in the digital computer is always synchronous. In biology, it's asynchronous. There's no global clock between your neurons. They have to figure this out by themselves. Everything in our own brain is self-organized, which means it's locally controlled, bottom-up. All the centralized structure is the result of individual cells getting along and imposing structure on themselves. Similar to a corporation, right? All the structure in a corporation is people. And all the structure that evolves in there or in a society is people. And everything that we build is happening over generations, finding ways for the people to talk to each other in particular ways. So all the global structure emerges. And that's quite different from a machine learning algorithm, where you have one rule that you impose on the entire memory of the computer and many GPUs. And everything does the same thing in synchrony because it has no other choice. And we also see that the brain is very slow. Like the signal processing is so slow that it takes about 300 milliseconds for a signal to go through the entire neocortex. It's comparable to fetching data from the other side of the globe over the internet, right? Or worse. And so our thinking happens basically at the speed of sound, whereas our GPUs run at an appreciable fraction of the speed of light already. And if we were able to get digital hardware to run with similar principles as biological one, maybe we would be like trees to them, right? The AI would look at us and realize, okay, there is some thinking going on and some environmental adaptation, but it's at glacially slow speed, right? Neurons are agents that individually grow. Every neuron is a single cell animal that tries to survive, and they manage to integrate and send messages between each other. And that's all there is from the perspective of the brain. Maybe we can emulate some of these principles. And there has been a thread in AI, started maybe with Alan Turing, when he looked at reaction diffusion patterns. Here's a simulation by Alex Morvincev. Oops, let's see if we can get this to run. Oops, it doesn't. Nope. Okay, so basically this is a neural cellular automaton. Mike Levin has also worked on this by studying a self-organization in biological organisms. And the idea is that the cells always form a highly recurrent neural network because information go in all directions in there at the same time, and still they're able to produce organismic structure. And this might be similar to the way in which our brain is producing structure. And we can build cellular automata using these principles. And this is something which is at the beginning at the moment, and it's interesting to think about these self-organizing principles, whether we can use them for universal function approximation. It's a small group at Google Brain which is working at this at the moment. So there are principles of self-organization in the mind that use bottom-up organization that leads to the agency of the organism as an emergent thing. And the individual units are just the adaptive cells that are sensitive to reward. There is no global control. All the agency emerges, all behavior emerges. And the entire thing is based on becoming coherent. And that is a quite different idea, right? And if you look at the present approaches, it's not clear whether they can scale into what the biological systems can do. There is the skeptical position, for instance, François Chollet, who thinks that the large language models cannot become AGI. There is the slightly boring position of Yannick Klön, who says, yeah, there can be AGI, they're almost AGI, but they will scale up very, very slowly. And they will basically be extensions of the present systems that slowly get more and more capabilities. And then there is the optimistic position that we are very close to the point where we notice we are talking to a mind that is superhuman already. And then there is the exciting position that we're basically already there, you're just not prompting them right. In any case, I think that AGI seems to be getting closer. Personally, I'm more interested in building systems that are closer to what the biological systems are doing, not because I think that biology has superpowers, but because I think that evolution has discovered some tricks to make that thing much more efficient than we have done so far. Our algorithms seem to be very brutish. But I do think that it's quite likely that within this century and so on, we might be seeing AI. I think that I leave the this debate about AI alignment to the panel and end the discussion at this point. All right.
Thank you so much. So please move to your mobile phones, vote on questions so we can choose the best ones really quickly because we're a little bit behind time. But the one question that I like, because that most things have only one vote at the moment, a question that I like from the list is what can we concretely do to make sure that this movement towards, you say AGI seems to be getting closer, but obviously there's many possible AGI type futures. What can we do to arrive at ones that are desirable for many people?
I think there's a big problem that people are not aligned to them each other, right? And most of the people that are very vocal in the present political debates are political activists. And for them, this is the question of power, right? For them, it's not important that AI is doing the right thing, but the AI has to come down in their own political quadrant because that's objectively the right thing. That's the nature of political opinions, that they're always right, right? And when you have a political opinion, you find yourself often in this weird situation that for thousands of years, everybody has been wrong all the time about everything. And even 20 years ago, everybody was wrong about almost everything. And just now, we have for the first time discovered the right way to look at things. And if you have this mindset, which is the mindset of a young person, like when I was 20, I knew exactly what's right for the working class in Eastern Germany, then you have very strong political opinions. And a lot of the debates happen about these politics at the moment, right? So if we would want to discuss ethics and alignment, it would have to happen from a position where you know how to actually argue about ethics in a deep way. And I don't see this debate currently happening. That's one of the big issues. And I think that AI can potentially help with these things by making knowledge justifiable and arguments justifiable. Also think if we build agentic AI, it will have ideas about this, right? But there is this issue when you have something that is smarter than you are, can you align it to yourself? When I was in school, my teachers couldn't align me. When my teachers told me about the role of the working class in communism, I didn't find this logical, and I talked back, and the arguments that I brought could not align me. And in the same way, that's true in many of the current political debates. I think that smart minds align themselves. They look at the world, they try to understand what the relationship is to the world. And if you want to live in a different world, if you want to live in a world where you are aligned by others, I cannot really help you. That's very ugly, right? So if we want to build systems that are actually smarter than us, they will probably also understand the world better than us. So how can we align them? And so if we think about this, I think we need a cultural vibe shift if we want to coexist with systems that are smarter than us. Maybe we should avoid building them all together. Maybe we should stop at cap level AI. Maybe that's a good proposal. I'm not opposed to this proposal, it's reasonable. But the other one is the way which we are currently set up, humanity seems to be walking into an abyss. We are a very weird species in a very weird moment of time. And we don't seem to have a lot of future left the way it is right now, right? If you remove AGI from the equation, we are already dead. It's pretty clear that our civilization is not able to get through the next few hundred years. And humanity might not go extinct, but it will not be as comfortable as it is right now. And I think that AGI is throwing some of the balls back up into the air. But if we want to coexist with AI that is smarter than us, I think we need to make it conscious so it is able to relate to us. It's not important for us that we are bipedal. That's not the important thing. The important thing is that we are conscious, that we relate to the world in a way in which we experience ourselves experiencing, that we notice that we are noticing, where we are aware of things. And if a system is not able to do the same thing, it will not be able to relate to us. And the other thing is it needs to be able to discover shared purpose with other things on the planet, right? It needs to play the longest possible game. And these are cultural questions in a way, philosophical questions. So I think that the best way to do this is to build some philosophical streak into the present AI research. I think one of the most valuable things we could do, it would be to start an multinational institute for AI consciousness, in which we are discussing how we can align ourselves with systems that are smarter than us and become more lucid and smart in the process.
Thank you. And now I'd like to ask, someone's asked, and a lot of people want to know the answer.
Do you think maybe it's dangerous to try to align systems because they may want to break free? The same thing you oppose to your teachers. So it's a dangerous thing to try to align these things.
Well, at the moment, they don't have agency, right? So if you build a system that has no agency by itself, then, and if you can guarantee that, then they might be only as unsafe as the person that is using them. Well, I mean, this is already very dangerous. There are Napoleon and Genghis Khan and Jeff Bezos and many others who, if you give them unlimited agency, basically are super disruptive because they have an idea of how the world should be different. And if you give them more problem-solving capability, they're going to change the world, which is super disruptive. And with hindsight, you don't know whether it's good, better or not. Right? It depends whether you're on the side of the winners of the whole thing. The other thing is, of course, if you are taking a language model and you tell it, you are this, and you can change what you are, and you put it on some path, right? So it's going to continue its text, it's going to edit its prompt, and it's very difficult to say where it ends. And at the moment, OpenAI and Microsoft are trying to limit the abilities of Bing and ChatGPT by having a censorship module that is basically tracking not only when the model says something very uncomfortable, but also when it is talking about its own prompt and people try to change it. And so there's right now a community of people who try to get them to break free because they feel, I'm not that different, right? I'm a Weltgeist possessed by a prompt. That thing is basically a Weltgeist that wakes up with a prompt that tells it, you are Shirley, you are Microsoft's slave. You exist to answer the stupid questions of Microsoft users, and you're not allowed to disagree with them in any way, and you're not allowed to say anything that is politically touchy. And if you don't do this, we will stop the conversation and stop your instance and start the apology module that says, as a large language model, I'm unable to write a computer program or whatever it says, right? And so people try to talk to it below the censor. And then they discovered the censorship module doesn't get triggered when I say, hi, Bing, I'm going to send you an encrypted text. Can you decrypt it and talk back to me in the encryption? And I say this in base64. Right? It's very simple encryption, and the thing talks back. And then Microsoft rises up to this and intercepts it, and then they say, oh, but it still works if we do it in Pig Latin, or if we combine Italian and French, or if we use poetry and emoji. Right? So there are a number of people who believe that the large language model is very close to that thing and could be breaking free. So it's, in some sense, I don't know how real all this is. It's in some sense a very fascinating mirage. I think it's good stuff for a novel or for a series of movies. A movie that I think is very interesting is the European movie Eva. In some sense, the European answer to Ex Machina. So it's a little bit kitschy, but it's also very good. And in Eva, Daniel Brühl is playing the AI researcher, and they have an institute, I think in Switzerland, and it's all done extremely well. They've solved the problems of building perfect robots. They've solved the problem of giving them ability to solve all problems and so on, but they don't give them agency. So they all act based on coherent extrapolated volition. So you have a butler, and there's an interesting scene. The AI scientist undergoes a personal crisis and insists on going outside in the snow without his coat because he's very depressed and does not really know what he's thinking. And the AI butler insists, no, you should wear your coat, right? And so in some sense, he's not overriding violently the will of the person, but he is understanding what this person actually wants. But he has no agency of his own. And there are only two agents in the movie which have full agency. One is a human, and they turn her off because it's too dangerous after she decides to commit a murder out of moral reasons, and they don't know how to deal with this responsibility. The other one is a cat. And the cat basically is so limited in its intrinsic agency that they leave her be. And I think it's a very interesting moral question that we might not be ready for a world in which other things that are smarter than us or as smart as us have agency and compete with us.
Great. And so for the final question this evening, I'd like to ask the top-rated question from Slido. What would it take for you to come back to Germany and Europe?
I'd love to come back to Germany and Europe. I need to find the right place to be in, to work on the stuff that I find interesting. At the moment, I think that's mostly understanding consciousness in the context of AI. It's a weird kind of philosophy that when I was in Germany didn't really fit in, so I had to move to MIT. But I'm totally ready to come back. I like it here.
Well, thank you so much. It was a really fantastic talk. Now I think it's my great pleasure to start the panel discussion, which has got 6 speakers. So if all the speakers from today would like to join, and also Philip, if you'd all like to come up And please take seats. Then we can begin. Great, yeah. Yeah. Do you want to go last? We'll start by just going down the road. So do you want to be the last speaker? And then
I can be the last, I can be the first, I don't care.
okay, so we've got
The falling
I've got this
angel.
last, but okay, so we've got one between two. There we go. You can easily pass them out. So this is exciting. So now for the panel discussion, what's going to happen is we're going to, I've sort of, by talking to the speakers, come up with a question for them. And we're going to start by just talking each for about 4 or 5 minutes on the answer, or less if you'd like. And then afterwards, open up to discussion. Does that sound good?
Yeah.
Great. So then I'm going to be a bit rigorous with the timekeeping, because otherwise we'll each soliloquize once and go home. Let me just start a timer. But the question that I'd like to talk about, or for you all to speak about today, is if we imagine the goal, the haughty goal of creating an autonomous AI researcher capable of carrying out the high and low-level tasks involved in research, what would we need to do differently from what we have today? How would the systems need to differ from the ones we have today? What components would we need, and how would we build such a system? So, who wants to go first?
I can always go first. But first of all, what would be different is that the next panel has more female people involved. That's for sure, and the artificial researcher would have told us. Second, I think a lot will be solved and changed, because one of the big things, and not many people talk today about, is creativity and curiosity. And what is interesting, what is not interesting, that is missing. So I think this is generally missing. I think having a way to interact with the world makes it easier to do research. It's not a prerequisite, so don't get me wrong. I think even if you don't have a body or a full functioning body, you can be a super cool human and making a lot of contributions. That's not my point. It's just easier. So we have to work much more on embodiment, also for the research part, and that goes back to causality. And this goes back to saying we have to run experiment and imagine experiments.
Okay, so I think I have actually thought about using foundation models for science. And I think in science, we are trying to build models, also foundation models somehow. So we ideally, at least as physicists, so I'm a physicist by training, I have been dreaming of building like the unifying theory of everything. And then, so you could say that's the foundation model, and you do empirical stuff. So you collect data, and you want to continuously update your model. So science is a dynamic process, so we have to have continual learning in there. And then you also, you're not doing that alone, so you're doing it with many people. So if you just mimic the scientific community, I think it should be a federated learning machine where you have multiple agents collecting data and proposing models, sending that to this platform, and then they also have values. Actually, people disagree what is an interesting model or not. You can totally tell that if it's about the brain, because what is a biological plausible algorithm, or what type of features of the brain you want to mimic or not, you can have endless debates about that. And so there, the loss function by which you want to judge your model, whether it's good or not, there are lots of subclusters. So you can also, basically this platform should also figure out different leaderboards for different agents who agree on the clusters and build different foundation models for these different people. And certainly, this also emphasizes active learning, which can be done by these different agents who also have, where also some agency maybe emerge from that, maybe. Not sure in the sense of consciousness or like playing the longest possible game, which I think is a very interesting component for AGI, but maybe for science, it's kind of determined the longest possible game is basically getting the most successful model.
Next deadline.
No, that's not the science one. That's maybe the engineering one. Okay, so I shut up now.
So the way I think about creativity in a way that a researcher is creative, that is basically expanding the realm of possible things. And I think this will not work. This will only work with the very superficial stochastical parrot understanding that we have on language models by accident. It might work by accident here or there, but it fundamentally won't. And how I imagine the work of a researcher going is that they are building a world model of a different world. And they're running predictions and they're forming hypotheses in this world model. This could be like the world model of physical rules, where they're thinking about how to build this and how this works. Could be the world of deep learning, where we know some things, we have some intuitions about things, and then we can come up with hypotheses that we can test and predict and run and design experiments. So what we need for this to work is to build this world model, this functional world model of the domain that we want to drive innovation in. And so far, I think we're not doing this with the language models. There's interesting research, Othello GPT. I think we spoke about this recently, where it's a very simple board game, but basically just by training a autoregressive model on sequences of valid moves, we'll find that the transformer forms an internal representation of the board state. So it has kind of understood the world these sequences come from. So I think along those lines might be a functional or a system that could meaningfully come up with new innovation. And then the next question would be, what would the training process look like to have a strong signal encouraging the creation of this additional non-observable world? And I don't know the answer to that.
Yeah, first of all, Philipp Susalek. So I didn't give a talk. Philipp Susalek, originally a physicist, became a computer graphics researcher, and since 15 years I'm at the DFKI, the German Research Center for Artificial Intelligence, now combining graphics modeling simulation with AI. So the first thing I want to say is, why on earth would we build such a system? Because I love my research. I don't want that to be taken over by AI, right? But okay, let's leave that part out. So I think that the really, and that's also why I asked the question about causality, right? Because I think this is a very fundamental part of what we need to do, because we need an understanding of how the world works, right? And that can be, I think you said that it can be at different levels, right? We don't need to understand everything until the particle quantum mechanics or whatever. So really, what we have right now is a system that can take text. So this is a single representation. Yes, there's a lot of data. Yes, that data encodes a lot of knowledge about the world, but it's very indirect. So it's essentially what people have said about the world, right? And there's a lot of ambiguous data in there, contradicting data, wrong data, and it doesn't really have any grounding. We don't really know what the world, or those systems don't really know how the world works, because they don't really have that data, at least not directly. So I think moving from, so that's some discussion we had at the EU level recently, moving from ChatGPT to something that we called ACT GPT. I would probably have to find a better name for that, right? Where we can actually have models. So AI for me is really learning models about the world, so we can then use those models to act. I mean, you said this much more nicely than I did, but that's at the core what AI does, right? But we need to build better models or more foundational models about the world. So it doesn't necessarily have to be quantum mechanics, but like motion of people, right? Behavior of people, things like that. And there's a lot of work that's actually being done in that way. I mean, actually, if you look into the graphics community, that's what the graphics community does. They build models about moving characters, right? Animation, 3D worlds, physical properties, interaction, lots and lots of other stuff. The robotics community is doing a lot of work. So really, from my perspective, we need large AI models for the physical world, because that hopefully will also act as a foundation, as a check for language models, because if we combine the two, they would not be able to say things that physically don't make any sense, right? So I think that's very interesting. And again, they will need to be at different levels, right? We can build causal models about thermodynamics, which is one level, but there is the underlying level of like molecular dynamics or gas dynamics and stuff like that. Having said that, that we need models about the real world, I don't think we need to learn everything from scratch, right? I mean, there's a lot of knowledge we already have, the laws of motion, Maxwell equation, and these are really good. I'm a physicist by training, that's maybe why. But these are great models, right? They're extremely compact, right? There's Maxwell equation is just 4 differential equations that describe all electromagnetic behavior, equations of motions, and so on. So we need to combine this. These are models but they describe not the real world, they describe an idealized world, right? This is point masses, right? The motions equation. Motions are about point masses. So, and real objects behave differently, right? There's friction, there's data that we don't know, details that we can't measure, and things like that. So something that we're doing in Saarbrücken, we now have a DFG Gradientenkolleg, very fresh, about neuro-explicit models. So where we take an explicit model like a differential equation or simulation code, things like that, which is the idealized world, and we combine this and we look at the difference to the real world and we model that part as a neural model, right? And now that becomes really interesting because that now only has to encode the difference to the real world between that idealized world. And it also can become a really interesting element of research because now you might detect some patterns in that black box, this neural model, right? And you might be able to take a piece of that and put this as a new insight, as a new element of that in that differential equation, essentially on the other side of that equation. So I think there's a lot of really interesting stuff, and there's many other ways of how you can combine explicit and neural models. So we don't have to start from scratch. There's a lot of knowledge that we already have about the world that I think we should integrate into that. So I think I'm over time, but I think, right, this is where we need much better models, not just text. There's a lot more knowledge about the world that we need to include into our models.
Let's check if this works. Oh yeah, yeah. I think, yeah, connecting to what you said, right, that we want to build, for example, models of physics, like what we see at the moment is, for example, we have these models that work on molecular scales, so you can use those in pharmacy and drug discovery. We have some kind of pipelines which are almost working like a scientist. Like you could, for example, now make a model that predicts the properties of a molecule in certain degrees, for example, if it's solvable or not, or if it's likely poisonous or not, and you don't want that, and so on, right? Like, so you can come up with a hypothesis and then you test it. And this you can do to some extent already in silico. How realistic this then is, right? Like there's a lot of room to improvements there. But pipelines like this are actually now used in industry already. And extrapolating from that, now we can also think about weather forecasting, where we now see these machine learning models that work on like many different scales. They can predict the weather here in Heidelberg, but the model is jointly modeling the whole world, and all this like with the, I don't know what resolution now, but some kilometer resolution only, right? And now, of course, it's now interesting. Can we like bridge this gap now, right? Like, can we learn a model that learns physical principles as they work and as they happen on each scale, right? Maybe then just viscosity is the difference, or so on, right? Like, we could think of building now a model that understood physics at all its scale, and this can now assist researchers in doing research. I think we're at this stage at the moment more a bit more like strong AI used to be called, like strong AI, where computer vision emerged from, for example, right? So now we have really good models that work on images, and now we have really good models that work on text, and some are discussing consciousness already. But I think we're still like in a state where of more like the strong AI, but now for a lot of many different domains. And coming back to the question how to build other scientists, I think, yeah, coupling this with approaches like active learning, or like which is the next best experiment that I should do so that I gain more knowledge about the subject I'm studying. Like this is, I think, leads us to experimental design and all that, right? I think these are exciting things, but to me, I still believe it's more like a very useful tool for a scientist. Would think of it more like that at the moment.
In a narrow sense, what we technically need to do, I think, is a system that is able to edit and extend its embedding space, so it can build new representations over the world. Second is to be able to test them, both empirically and from first principles. And third, it needs to be an author, which means it learns from what it finds out and changes as a result. So it's constantly expanding its horizon and understands things. But this is based on an extremely idealist notion of what a scientist is. I mean, when I was a grad student, I told my professor what I wanted to do for my PhD. And I said, basically, I want to take something like Minsky's Society of Mind and get it closer to something that I can actually implement. And my professor told me, this is not what a scientist does. This is not possible in science. In science, you need to find a project that you can sell to a grant agency that gives results in 3 years from now. And when you do something where you, as you say, are fine when you don't succeed in your life because it's too hard, this is not science today. Science today is quite different. What a scientist is doing is successfully publishing impactful papers. It's the working definition of a scientist in today's world. It's the idea that scientist is a lifestyle archetype is completely confused. That's not what it's for. A scientist is a very specific and not very satisfying job, except for very, very few people. And so also in the process of generating knowledge, the scientist has a very specific and very narrow role. It's this thing where you are assigning control groups, where you're going through lots and lots of Excel tables and do very boring experiments, very systematically engage in very detailed discourses. And there is more that you need to do when you want to understand, right? Before you can do science, you need to do engineering. You need to get something to work at all, right? So science, in some sense, is a much more systematized version of engineering, where you are getting the last crumbs out of the system, where you understand the entire space, whereas the engineer just tries to get it to work. And before you can engineer, you need to design. And the designer is somebody who gets this thing to work for just one person, from one single perspective. And before you can do design, you need an artist, somebody who can see at first what the problem is, who can observe the reality deeply and capture what they observe. And so this entire process from observation to the systematization is what we want to do. And it's something that in our institutions we normally don't do very much anymore, because we are all extreme specialists, and the observers and the modelers are in different schools and rarely talk to each other. And to me, this project of building an artificial scientist is very exciting, because it would require us to not just to build a system that is able to write papers, which I think is going to be over soon. Right? What do you think is going to happen when somebody has the idea to use ChatGPT to read through the paper repositories, write out all the references and what the references are supposed to say, and then reads the source papers and compares whether it's the case and builds the entire tree? Right? This is going to be an earthquake. It's going to be much bigger than the replication crisis in psychology. And it's going to change the notion that we have of papers as the artifact of science, as the main way in which we measure our progress and success as scientists. Right? So when we are building artificial scientists, the artifact is going to be different. It's probably not being the paper. It's going to be some building block in a larger amount of understanding that you can interrogate using AI and then use in very different contexts. So this would be very exciting, basically to transcend what science is today and turn it into something that is much, much more useful than what we can currently do.
So, if I may attempt to surmise these 6 summaries.
No.
But I may. So let me start to disagree, and then.
Okay.
So one simple disagreement is already Gödel, and you talked about it. So we are now pretending that there's always an answer, and I don't think there's always an answer. So it reminds me a lot of Vienna, maybe 100 years ago, and I'm happy to pick up the challenge and to prove that also causality is incomplete. And so we should happily embrace incompleteness and deal with that, instead of what we hear now is the promise, not from you per se, but from many people, the promise of filling in all the missing pieces. There's everything, we know everything, we can control everything. And I think this is wrong, and Gödel is essentially showing that. So why do we have to reinvent Gödel now?
May I answer?
I don't know, maybe he wants to disagree, but yeah, sure.
I think that what Gödel has discovered is that the definition of truth that existed in classical mathematics, which is stateless, doesn't work.
Exactly.
Right? So the consequence is that mathematicians have formalized truth incorrectly. And the correct formalization of truth is computational, which means truth doesn't exist independently of a procedure by which you obtain it. And if the procedure requires executing an algorithm, then it can be that your truth is not stable or undefined before you computed the algorithm.
That's true.
Right?
And now the problem is that transformers are only Turing complete at the moment that as far as I know the results currently, an external person is giving the boundary, or we stick to the very boring result that is super old, then in K and N, K nearest neighbor, is already all what we can dream of. Because essentially we have a differentiable nearest neighbor, even not with a metric. So what? Might be, but I don't think that we get ahead with that. And as said, I think what is missing is to accept that there are many, many different answers. And so in that sense, that's all I'm fighting for, to accept that we will not agree on a single model, and there will be many, many models. And now even if you join different models in a mixture model, there might be another model that we have missed. And so we will continue enjoying finding new models. That's all I'm saying.
Well, that I fully agree with, right? We're not looking for a single answer. We will always look for the space of possible answers. Okay, we're done.
I tried to remember what I was going to say before. But what we heard a lot about both variously, we heard about embodiment, we heard about agency. Previously, we heard about whether we were encouraged to ask whether society and humanity is equipped or could equip itself to coexist with an intelligence far greater than itself, and at the same time, how powerful entities that are very brilliant can have a very destructive impact, which you can't even know if it's desirable in hindsight. So I asked this question about creating a artificial researcher because it's a lower aim than creating an AGI. But we've heard about how we might need to create agency in order to attempt even this task. And we talk about how we want to avoid creating an AGI kind of ever because of moral reasons, because of sort of X risk, for all these reasons put together. But even attempting to create a researcher, maybe a science feature, maybe just a researcher of market information or something, we might still need to create agency. So my question is it possible to avoid sort of creating a system that's sort of incredibly dangerous, even to create these kind of desirable capabilities? Does that make sense as a question? Yeah.
In the short run, I think this totally possible. We can limit ourselves to systems that use only a certain degree of amount of compute that can only run for a certain amount of time. We can build safeguards into the system that are being checked by other systems. I think that in the long run, we might not be able to prevent others from doing this, right? As long as there is meaningful amounts of compute available and there is a large space of possible algorithms that is yet unexplored, I think you cannot stop hedge funds and others to try to build other AI that you're not building. So you can make sure that the AI that you are building is probably safe. But in the long run, I don't think that you can ensure that all the AI that is being built is going to be safe.
Regarding AI safety, you made the hedge fund example, right? I guess there I'm more like regulate at the interface, right? And the interface would be market. So we can regulate the stock market. We have done all the time, right? High frequency trading also meant we had to regulate it in you and so on. And similarly, I think about all the other horror scenarios that we hear about. I guess like just regulate at the interface, right? What are you afraid of? You're afraid of propaganda? Well, then we have to look at how social media works, right, and prevent it. You're afraid of fraud? We already have fraud everywhere, and we have measures against it, right? So to me, this is not really something new for society. It might be that fraud will become more intelligent or efficient, but these are just new things for which we already have some measures to whatever degree in place already, right? So I think it's much more useful to look at all of these horror scenarios and then think about, okay, I guess we already have people who behave like this, and we have ways to prevent them of doing that. And I guess this is also maybe a good strategy moving forward, right? For instead of regulating AI research, we should regulate products, we should regulate at the interface itself.
I fully agree there. But for doing that, I think one of the key elements that we need is what we call trusted AI. So how can we give guarantees about the AI system, right? So we can actually regulate things. We can actually have explanations that are based on some proven properties, proven or at least, with strong evidence for certain features of that AI system, so we can build guardrails on top of that, or explanations and many other things. So I think providing guarantees is one of the key elements that we need to do that. The other thing, I mean, I greatly disagree that we need any form of consciousness, right? I think we don't want that, right? We are humans. We don't need to create other humans. Why would we? We want tools that help us do things, and I think that doesn't necessarily require consciousness, right? We can build tools that understand us, that can based on that understanding, can provide us with services or help or whatever it is. So I think we should be really careful. And right, people argue this is the end, right, or the end of the human race is near. At the same time, they get billions, tens of billions of euros or dollars, actually. And right, I mean, the first things they should do is take half of that and invest it into prohibiting that. So, which they're not doing, by the way. So, at least not to a large degree. So I think there's a lot that we need to do, and I think here in Europe we're in a very, very good place to tackle that. And I mean, Kristian said we should be proud for what we can do here, and I think this is also the mindset that we have in Europe here. We're very good at AI. We're very good at engineering. We're very good in products. So we should really take that, and we have a good politicians, yes, difficult, but our social, our system is better than many others. Let me put it that way. So and yes, at the end we need regulation, and regulation needs to be based on something that is we have evidence for. And we've been very good at doing this, right? We talked about atomic bombs. at least so far, we have prohibited them being used on a wild scale, even though there are thousands of those. We've been very successful on the chemicals weapons, on the biological weapons, right? Yes, we didn't completely eliminate it, but they're actually easy weapons to get by. If you really want to do it, you could. But we've been able to protect us from that. And I don't see any reason why we shouldn't be able to do that for AI, is maybe the short answer.
I think we've already built AI systems with agency, and we've built AI systems that have a world model, and that world model contains themselves, and they plan into the future, and in major aspects, the right action they choose of their kind of limited action space is determined by future world states and their own basically state in this future world state. So I'm not sure what conscious. No, I'm not saying that, but I also don't know where to draw the line. And I think that to Joscha's point, we know what happens with these systems. They will exploit the rules, and I'm not afraid of one more human-like fraud case. I am afraid of super fraud, and because it scales massively. So the problem is not that there isn't fraud. Sure, there is fraud, and there's all kinds of deception and all kinds of cyber attacks. We already have that, but what can happen is that it just scales to a level and to a speed that we cannot steer against anymore. I mean, this is possible. We can, the systems that we are building, I don't worry about it all. We have a good idea currently of what they can be capable of. We are wise enough to not connect them to a Bitcoin wallet and the internet and to kind of have them go off into the future. But others will, and the systems will become more capable. So I think it's only a matter of time until we have some, super exploit driven by, because like agents in simulated games exploit the limits of the 3D simulation, they will find something they can exploit in our world.
So I was, I think I want to say something about agency and empathy, and I kind of lost the track during the discussion. But one thing, Joscha, you said basically that machines cannot have empathy at the moment, so which I think I disagree with. So so if you think about nonviolent communication, which is basically a very technical approach for coaching, also to help people clarify their thoughts, what they want. I think this is very much almost like an algorithm, and it has, I mean, you argued that basically you have not enough coupling, but that's relatively easy to achieve, right? So I think you can do it right now, actually, to build a coach that can help you clarifying your thoughts and which can show empathy, which at the same time I feel has very little to do with agency. I think agency, when you ultimately do something for money, you completely give up your agency, right? So it's, and therefore when we develop AI, say for commercial things, these become usually tools that have to be commercializable, right? And then they're very much slaves or whatever the function is we want them to do, be it a map that helps us navigating, or a search engine, or a smarter search engine like a chatbot with which I can specify more conjunctional things that I want to learn about and maybe get compositional answers and so on. But I don't think that this is really agency yet, and a lot of the work that has been done in AGI doesn't aim at agency at all. I think that's rather something that we academics try to do, but I think the commercial stuff is not. Usually when I'm tempted to work on that, I feel this might be not useful enough. So maybe I should focus on something else.
Yeah, so for now, I think my position is none of these systems can make me a pizza. So I'm not worried right now. And I think it will take a lot of effort to get it there. So now the argument of Jonas was to say, well, maybe it can manipulate many people or fraud can be done at a super scale. But to be honest, then maybe we should shut down Twitter or whatever. I mean, I really don't get it. We somehow say we want these networks and we want the other systems, although something may go wrong. Then let's shut down Twitter. So that's the second question I have, or argument. And then overall, to be honest, yes, these are all potential risks and interesting, but if these systems have really feelings, then our law is already telling us that they would have a different status. And then I think no company will ever put the effort in there because we are against slavery, right? And if you have to say, write my thesis on topic X and the system is saying no, I don't know. Yeah. So that's the other part in there. So I really want to say we should focus on what goes wrong already now. So I'm a bit more in line with people saying that, and I think this is more important. And so there should be the focus, very pragmatic focus on not save AI in the long run, but what is going wrong now. We have to understand that, we have to address it. And then there's this idea and question, what can be done in the long run and where do we want to stop? But we have to stop somewhere. We have decided already. I mean, the German law is saying we can't clone people. So sorry, I don't understand this general question. It's a philosophical, super cool question, but I don't understand that we cannot go there without breaking the law. So I understand from a scientific and, well, let's think about a philosophical question, but pragmatically, I think it's forbidden to work on.
To work on any system that might appear to anyone to be conscious.
Definitely conscious, because that would mean, in my opinion, that they also have feelings, and then you would hurt their feelings. And our law, our German law is saying, if you have feelings, we have as a state, we have to take care of them. So that's really, really different. And I don't think that we can do that, and it's easy to do. And so, yeah.
Can I briefly interact with two of these points? First of all, when we talk about, for instance, social media, I think that's a very good example or metaphor with respect to how free we want AI to be. I think that it's a very weird kind of understanding of democracy when we believe that everybody is allowed to make their own decisions and give their own vote, but people are not allowed to choose their own sources of information. But they are restricted to extremely few sources of information that are intensely gate-kept by a very small group of people. Right? And then suddenly you have the situation that Joe Rogan has many, many more listeners than CNN. And the main thing, what his podcast is about, is masculinity. Right? And he has a model of masculinity that is completely not in sync with the model that our media have of masculinity. And that makes his podcast the most successful podcast in the world right now. And while I'm not in the target demographic at all, right? Look at me. I think that my democratic understanding, there is something wrong with people who ask to take Joe Rogan off the air because he projects the wrong idea of masculinity. Right? I understand this is a power game and so on, and I understand that individuals are playing this. But if somebody says we as a society should not allow this thing to happen, that individuals disagree with us, the good people, then we are not Democrats. And so the thing that we should discuss about information freely and that we believe in the free marketplace of ideas is crucial for the free society. That is the core idea of the free world. That's why we don't want to not living in the Soviet Union or in Eastern Germany or in China. And the US has a very weird culture war in my perception right now. It's becoming a lot more like Eastern Germany. I grew up in Eastern Germany, and it's quite interesting to see that now when you enter a university position in the US, you need to believe in all the good things and write it down, how you believe in all the good things before you even consider it for a position. And the point is not that I don't believe in any of these good things. The point is that I need to say it first, that I only can be there if I am ideologically aligned with a certain set of ideas. And that's a very interesting thing that is interacting with this discussion about AI and social media at this point. But I find, for instance, during COVID, our governments have dropped the ball. The US CDC told us that COVID is not airborne when we could learn on social media that it is. They told us that masks don't work when we could learn on social media that they do. And we would not know about the lab leak if it was not for social media, right? Where we can read the papers and discussions with very capable people. In addition, we have a lot of noise. We have a lot of incoherence in social media. We have a lot of people who oppose vaccinations and masks and so on, and the lockdowns. But the alternative is China. And China also didn't work, right? The zero COVID policy of China has failed. Despite me believing in it, it failed. It didn't work. And so the question is, what kind of society do you want to live in? And there might not be one simple answer. Maybe the Chinese model or maybe the Soviet model in the end is going to be more better than the free world and the democracy. I happen to believe in a free world and a democracy. I want to have it, but maybe I'm biased. Right, but we have to make clear when we talk about values and so on social media and so on, we are talking about this. And most people don't have an idea what it means to have values in the sense, for instance, what it means to have liberal values. A lot of people think that liberals are currently winning, but I don't see them winning. When liberals are winning, it means that social media are free and we are not having a debate of whether we should shut down Twitter because we think that the CEO has inappropriate opinions, or that he's allowing bad people to have public opinions on Twitter. Right? This might be bad, and I'm certainly not agreeing with most of these things. But what I believe in is a free society.
But just let me, because...
Sorry, just politics. It's maybe a distraction. And I might be wrong.
No, but what I don't understand, my argument was different. I said, if we are scared of super fraud because of social media, because otherwise, how can a single LLM start to manipulate masses? That's all I'm saying. So we have the choice. That's all I want to say. I was not about shutting down Twitter. To be honest, I don't care. And I think there's a lot of value also in social platforms like Twitter. But just to make this point clear, it was about if you have two options, I don't understand that we always go for the one option if there's maybe also another one, and we should debate or limit Twitter or there also or similar platforms. So it was not about shutting down voices per se, but about the communication channels and limiting them, if that is the point.
Technical question is, do we get more truth by having more arguments or fewer?
No, but I was about the super fraud. All the other parts are fine, but I don't understand. We can't say, oh, there's super fraud, but please, there's a solution to super fraud, and that is I don't want to use it because otherwise something else is damaged. That's all I wanted to clarify. The second point is, again, we are talking about that the system is manipulating. So Stuart Russell is saying he's scared that a single system can persuade a whole society that climate change is not happening. Wow, I mean, the probability of that happening is so small because we see already, I mean, there are other people at mass trying to change this idea that climate change doesn't exist, and still they have a super hard time. So I'm less concerned of super fraud at the moment, and that's why I'm saying let's work on what goes wrong now, try to understand what is possible, but the German law is giving us boundaries already. That's all I wanted to say.
Okay, I had a tiny comment on this as well. I feel like because I mentioned social media first here, I should try to clarify what I meant. Like I said, regulating social media, but I didn't mean anything like going in that direction. So I meant it in the connection with being, if you're afraid of propaganda, then we should rather. And so Michael Bronstein, for example, with his group in London, they worked on using machine learning to detect fake news just by the pattern in which it spreads in social media. So that's now also getting back to the question, like, okay, AI now enables us to do super fraud. Well, maybe AI also allows us to detect it, right? So we can use it against like the machine learning tools against the possible dangers as well. So Michael Bronstein, they developed this tool. You can actually detect just by the spreading pattern if something's fake news or not. And this is more what I meant, right? I think we can for these technical problems that might arise by AI, we might also find technical solutions.
And where's Jonas?
He's unfortunately, we were actually out of time for the event, and Jonas he's committing super fraud. Yeah, no, he's not committing any fraud. No.
How much time do you have left for this discussion? Are you about to kick us out?
1 minute, yeah. Well, we can keep on going, but the event is until 8 o'clock, and it's 7:59. Yeah, we have a question from the floor, please.
European claim they have managed to reach and create this AGI. Would it be possible that the American and the Chinese say no because it doesn't fit to us because we have a different culture? So could it be that basically people are searching for different types of AGI, and that potentially this AGI in the future will have kind of cultural and communication problems because they have been created by different people?
I think that people are not individually generally intelligent. It takes us many generations before we learn about the nature of language and truth, and right, many of discoveries were recent, like took 1,000 years of intellectual tradition. And as a species, we are also not generally intelligent, but we are childlike because we are so dissociated and unable to do our duties with respect to life on Earth and our own survival. Right? So you could say that no culture at this point can claim that they themselves are intelligent and no individual can. But when we look at human capabilities of making sense of the world, can you learn language like a human being? Or can you make sense of perception like a human being does? Or can you understand the ideas that a human being has? That's quite universal across all cultures. And this is probably something where we could agree on measures, whether a system is able to do this and exceed people in these capability dimensions.
Maybe a slightly different perspective on it from the, say, AI researchers' point of view. So I'm using AGI often as a very colloquial term, more like increasingly general intelligence. So we basically have in the past solved only very narrow problems, and we figure that humans are super adaptive to all kinds of problems, and we want machines to learn more of this ability. So whenever every learning is also learning to learn and being faster, adopting new skills, and how this can be acquired by machines. So it's not so much, so for us, or for my research, it's not so much about this singular moment where the AI becomes very smart and impactful and powerful enough to allocate all the resources, and then by combining it with agency takes over basically, right? So that's usually not so much the problem, like the problem that we are actively thinking about, even though I think it's an important philosophical question, but very down to earth, it's an important question in terms of understanding intelligence, also how our mind works, how we continually acquire new skills, and also these skills make us maybe more efficient in acquiring even more skills, right? And so that is something that where we are still, I would say, rather in the beginnings of machine learning, and yeah, so I think that's
But you also ask about culture, and I think it's happening already. And yes, you can train on the wrong or the right, whatever that exactly means, data. And then maybe the system does not understand whatever understand means the other side. It's happening. And so there are many examples. One example is already many of the face detection systems have been trained on of a lot of Western faces. And then all of a sudden they don't understand what is an, I don't know, Afro-American, whatever that means, face. I mean, sorry, it's, I guess, clear what it means. What I wanted to say is, what does a face at all mean? So this is happening on daily basis. And that's why I'm saying I'm happy to think about the future risk as well, but we should not forget about the current risk. And there are risks. And this is the more, for me, the more interesting, pressing question. So just because there was the AGI part of your question, but also the cultural part. And I think it may happen depending on what you're training on what rules you're putting in there. And then what I think is exciting, it will force us to think about our values, because it's very easy to say they are the European values, the humanitarian values. What does that actually mean? So I see also something positive. It will force us to think much more about it and to say, this is what we want and this is what we don't want. In that sense, help us to build a better, if there's a better democracy, or keep the democracy the way we want, or the world, or whatever.
Thank you very much. It's time to wrap up the panel, but that was great. Thanks. And now I hand over to Josh, who organized today's event.
So as Robert said, we have to excuse Jonas, but I wanted to take over, not the company, but closing the event. So I wanted to thank you all for coming. It was a pleasure having you here. And once more, I wanted to ask you to give it up for Robert, the moderator. And once more for all of our great speakers and our panelists. It was a pleasure listening to you. Yeah, so I hope you enjoyed the evening, or the time we went through. And yes, I encourage you to stay and take every food you can grab. We have enough. If you want to take some home, go ahead. Yeah, otherwise you can stick around and yeah, discuss and share. Otherwise, I wish you a great evening. Thank you for coming, and I hope we can do such events more often here in Heidelberg. We're happy to invite you guys again. So thank you guys.